Okay, let's talk about experimental research. This is the type of research that, in a dream world, we would all try to do. Because when we can run an experiment, we can actually say X causes Y. And as we talk through some of the requirements for running an experiment, you'll see why we often cannot run an experiment. But in an experiment, the experimenter is objective. The phenomena occurs, and it occurs in a strictly controlled environment where one or more variables are manipulated. And because the experimenter can come in and manipulate that variable, the experimenter, as long as the experimenters held the other variables constant, ruled out the extraneous variables, then the experimenter can say that the thing I manipulated caused the outcome. This chapter has a lot of vocabulary, so you might even make yourself a little list. Make sure you're familiar with the idea of random assignment, of the extraneous variable, of manipulation. Okay, so here we go. Some examples of experimental research. They happen in field experiments. And the original experimental research was done in planting crops. Some of the greatest statisticians came out of the Guinness Brewery over in England, and they did their research in crop yield and how the quality of the crops led to a better brew. So, kind of fun to think about where some of these concepts came from. Also, a laboratory experiment. These are usually very controlled. And then internet experiments, moving us into the new age. Okay, so what an experimenter needs to do is to manipulate the independent variable. Remember, we tend to say the independent variable is the thing that starts off the process, and the dependent variable is that outcome, the thing we measure at the end. And so you can imagine in pharmaceutical studies and a lot of studies, you can manipulate this. You have your treatment group, the group that's taking aspirin, and your control group, the group that's not. You might have a placebo here so that your experiment is a blind experiment. You might not even tell the doctors who has the placebo and who has the aspirin so that your experiment is double blind. The doctors don't know, the participants don't know. You might, in these original experiments done on the crops for Guinness Brewery, the experiments were more about the amount and fertilizers, a low, a medium, and a high amount of nitrogen in that fertilizer or potassium. In education, we might do experiments where we vary the type. So this group gets strategy one. This group learns how to spell with tiles. This group learns how to spell with a typewriter, and this group learns how to spell with paper and pencil, if you remember back to that Cunningham study. Okay, um, we have in all of research, we have confounding variables, this idea of extraneous variables. But what happens in an experiment is because people are randomly assigned, we assume that we'll have the same amount of that confounding variable in each assignment group. So here's an example. Let's say we want to demonstrate that smoking leads to lung cancer. And this is something that we wanted to demonstrate for years. We would have to take a huge group of people and randomly assign them to smoke and randomly assign the rest not to smoke. And that would be the only way we could show causation. Because otherwise, there might be something about the people who choose to smoke or who become smokers. Maybe they were exposed to secondhand smoke from their parents in all of their growing up years. Maybe they have been more involved in certain activities that lead to lung cancer, and it's not the smoking itself. Unless we can randomly assign people to smoke and not to smoke, then we can't say for sure that that's what causes lung cancer. And this is one of the big challenges that come up with creating an experiment. Okay, let's move on then to random assignment, and be careful. I have a question on the test about this. Think about, how is random assignment different from random sampling? For example, if I want to do a huge study on maybe cancer treatment, and I ask for people to volunteer. But once they volunteer, I randomly assign them to the chemotherapy group or to the radiation group. I do not have random sampling because I ask them to volunteer, but I do have random assignment because I'm placing them in the groups. And so I still have an experiment. Okay, then here are some techniques that people use. Sometimes they match as a control technique. We see this a lot in medicine. If I have 50 men who've had a heart attack and I'm interested in preventing that second heart attack, I might want to match them to 50 men who have not had a heart attack. I might match them on age, activity level, cholesterol level, maybe ethnicity, region of the country. The more I can match, the more I can control for those variables, those confounding variables. Okay, so what I want to do is hold those variables constant or possibly build them into my research design. One way we can do this is with counterbalancing, and you'll have to look in the book. They have some charts that show how you might counterbalance. For example, all the participants get all the conditions but in different orders. And sometimes the counterbalancing is so complicated it looks like a big Sudoku table. It's kind of fun. I think counterbalancing is used a lot more with agricultural studies than with education studies, just so I'm not going to test you on those designs because probably you won't be exposed to them very much. Okay, so let's talk about weak and strong experimental designs. Okay, so a weak design would be I have one group and I give them a post test. This is very weak. What can I say if I have a group, I teach them how to read, and then I give them the post test? Perhaps I can compare them to some norms, but otherwise I don't have much to say about that treatment effect. For all I know, they did well on the post test because they brought jelly beans that day. So a step up, but still a weak design, would be a pre-test, post-test design. And this is one that we often need to use, and it's because we have a group of participants, we give them a pre-test, we give them the treatment, and then we give them the post-test. Why not have a control group to compare with? Well, maybe the treatment is something that we believe in, that we think is good, and we don't want to withhold from anyone. Maybe we are doing research on our class, and the entire class is going to be exposed to this new way of learning reading, for example. But this means we might have problems with history or maturation or statistical artifact. So don't forget about these from our previous chapter on validity. They're important, and I'd like you to at least be able to find them in the book and explain why these might be a problem. Okay, what about a post-test only design with two groups? So I've got two groups, and I'm going to give them both the post-test after I give one group the treatment. The other group doesn't have the treatment. Well, the big problem here is I didn't randomly assign them. Now, this is a great way to start a study, and we do this a lot in education. I have Mrs. Jones' class and Mr. Smith's class, and in Mrs. Jones' class, we've got iPads, and we don't in Mr. Smith's class. And at the end of the year, I'm just going to ask the students what they were able to learn and compare the results. Problem is, there may be something different about the atmosphere in Mr. Smith's class that is showing up as a significant result. Okay, so strong experimental designs are when I use random assignments so I control for those extraneous variables. And so here's a really strong design. It's a pre-test, post-test, but not only do I have a randomly assigned treatment group, I have a randomly assigned control group. And this way I can look at their pre-test results and make sure that all my students are about in the same place. I can randomly assign them to treatment or no treatment, and then I can look at the post-test results. It is a beautiful design, as the authors say. Okay, Likewise, if I only have the post-test, not the pre-test, I still have a pretty strong design here because I've randomly assigned those students. I can pretty much assume that the pre-test should all be about the same and that the post-tests are indicative of growth in the treatment group. Okay, then the book has a bunch of information about factorial design, and I won't test you specifically on this. It's something that you'll get to practice in a doctoral program. It's really kind of fun. It's the idea of I have two or more independent variables that that are both applied to the same group. So I have males and females, but I also have undergrads and graduates. So now basically I've got two categories, say in gender, which I probably should have more, and I have two categories in student status, which I probably should have more there too. But let's just say it's 2 by 2. Well, now I have four categories of my male graduate students, my male undergrads, my female grads, my female undergrads. This becomes a factorial design because I can talk about just the gender, or I can talk about just the student status, or I can talk about how those two combine. Sometimes there's an interaction, and we saw this in a study we did with Chinese and Indian students, male and female. We found that the Chinese females were more driven to learn grammar, English grammar, than the Indian females. But then the Indian males were more driven to learn grammar than the Chinese males. So there was kind of this interaction. You had to know not only were they Indian or Chinese, but were they male or female. Okay, factorial designs have a lot of advantages because you can test. I can ask three questions then. I want to know about gender, I want to know about student status, and I want to know about the interactions that go on there. The disadvantages, you've got to collect more data because now we need a big group of male grads and a big group of male undergrads. Each one of those groups needs a substantial representation, and by big I mean 30 at the most. That's pretty big though in Wyoming. Okay, repeated measures designs, very common in education. We give a pre-test. We give a test. Well, think about the map test. We give it again in the winter sometime, then we give it again at the end of the school year. Any kind of a study where we look at growth in that map test would be a repeated measures design. Once again, the book has some good charts and graphs showing you how those can be studied and how those can be planned and done. And finally, I just wanted to point this out. The book talks about a mixed model. Don't get that confused with mixed methods. And I get them confused all the time. I mean, the two M words. But a mixed model means I'm combining, say, a repeated measure with a factorial design, or I'm combining even a t-test with a chi-square test. A mixed model has more than one statistical test, whereas a mixed method, as we learned last unit, is that combination of quantitative and qualitative research. So good luck with the vocabulary in this chapter. It's important for those who do experimental research.